Well, I know how you guys approach these, but I actually like them a lot. You approach them with an oh, you make those funny sounds, and then you come and ask me to do it the next day. Well, I'll do it now. I'm going to look at these, and I find either your x's are going to cancel each other easily, or you've got some stuff going on here. But I kind of look at this y or the z here, that's the opposite sign of these other guys. If I multiply this top equation by a 2, it's going to cancel with this. If I multiply this top equation by a 3, it'll cancel with that. And that's pretty straightforward, and that's the way I'm going to approach it. Okay, it's not to say that you shouldn't get rid of x's, because I think arguments could be made there, but that's what I'm going to do. So, multiplying by 2, my goal is to have this equation cancel a z with this equation. Okay, so let's go over here, and I'll perform that operation. 2x minus 6y multiplied by 2 plus 2z equals 26. Right underneath that, I'm going to write this equation as is. 2x minus y minus 2z equals 2. Combine those equations together, I get a 4x minus 7y. Those go away, and it's equal to 28. Okay, nothing can be done to simplify. I might look to see, can I divide by 2? And 4 times 7 is 28, but that doesn't necessarily help in terms of simplifying. I call that equation 4. This is equations 1, 2, and 3. Your goal in these is to create an equation 4 and an equation 5 that are compatible in terms of the variables they have left, and only have 2 of them. So that's why I said at the top that I was going to get rid of z. Again, combining it with this equation. So this time, instead of multiplying by 2, I'm going to multiply by 3, because that'll allow me to cancel z with the third equation. And I do it in such a way I can just dump this right underneath. It saves me time and space. So distributing the 3, I get a 3x. I get a negative 9y. I get a positive 3z. And that's equal to 39. Okay, combining those together, I find good news. That's a 4x right there. That is a minus 7y. This goes away as we hoped. This is equal to 38. I say good news because I noticed the negative 7, and then shortly thereafter, equation 5, I noticed that there's a 4x and a 7y. Okay? So regardless of which one I want to get rid of, let's pretend that we want to go through this thing and we multiply this equation by a negative 1 to get rid of either x or y. Look what happens. Negative 4x plus 7y equals negative 28. These cancel. This does not. I end up with a 0 equals 10. That is a false statement in most countries. Because it's false, if all of our variables go away and we end up with a false statement, the answer is no solution. If this was a 0 equals 0 prospect, if we multiplied the two equations and everything went away completely, 0 equals 0, the answer would be many solutions or an infinite number of solutions.